Hi, my name is Monis, and today I'll be going over some physics problems. So today's problem involves the moon, and the prior information they give you is that the mass of the moon is equal to 7.35 times 10 to the 22nd kilograms, and that the radius of the moon is equal to 1,731.1 kilometers, or which is also equal to, which we have to use in this problem, 1,737,000 meters. So the first problem they ask you is to find the acceleration, or in this case, g. So we know that in this problem, the only net force is the downward force, the downward pull. So we can set mg equal to the gravitational constant times the mass of the Earth, mass of the Moon, over r squared. So the mass of Earth, the mass and mass cancel out. So you're left with the g, which is the free fall acceleration due to the moon's gravity at the surface, is equal to 6.67 times 10 to the negative 11th times 7.35 times 10 to the 22nd over 1,737,000 meters squared, and that gives you a free fall acceleration g of 1.62 meters per second per second. So the second part of the question asks you to find. So they say if you put a satellite in circular orbit around the moon that has a speed of 500 meters per second, what is the radius of the satellite's orbit? So again, there's only the downward pull, the net force. So we know we have two equations, which is one the net force is equal to mv squared over r, and we also have one saying that um, net force is equal to the gravitational constant times the mass Earth mass Moon over r squared. So we can set these, obviously we can set these equal to each other. So the masses cancel out of the Earth, and then you're also left with only one r. So this gives you, and they're asking you to find the radius. So you have v squared equals gm mass of the moon over r. So r is equal to 6.67 times 10 to the negative 11th times 7.35 times 10 to the 22nd over 500 squared. So the R is equal to 19,609,800 meters. And finally, part C says, what is the period of a satellite's orbit? So we use our generic formula. V is equal to 2 pi r over t. So that means t is equal to 2 pi r over v. And we substitute our values in that and they say if it's moving at 500 meters per second, so that's 2 pi times r over 500, and that gives you a value of the period of a satellite's orbit in seconds, which is 246,424 seconds. And that is how you solve a problem like this with regard to circular motion, and in this problem involved the moon. Thank you.